Hello students, I am Ritu Gupta. I'll be talking about linear equations in one variable in today's session. Let's start with the definition of linear equations in one variable. So first of all, before understanding what are the linear equations in one variable, let's first try to understand what are linear equations. A linear equation is an algebraic equation in which each term is either a constant or the product of a constant and the first power of a variable. An example would be 2x plus 9 is equal to 3. In this case, we see x is the variable here, 2 is the coefficient for the variable x, 9 and 3 are the constants, and 2x plus 9 on the whole makes an expression. So a variable is a quantity that may change within the context of a mathematical problem. Typically, we use a single alphabet to represent a variable. So what we're trying to say here is that 3 and 9 are going to remain constant wherever you take them. But x is something that in this expression itself could take different values. So if you take x is equal to 1, you could take x is equal to 2. You could take any value of x. It's a different thing that the equation may not hold true for all different values of x. But x is something that we're taking as a variable, something that could change its value as we change the context of the problem. An equation is a statement of equality of two algebraic expressions. So in this case, we say 2x plus 9 is the expression on the left hand side and 3 is an expression on the right hand side. And when two expressions on the left hand and right hand are separated by an equal to sign, that forms an equation. So let's see the representation of linear equations. Some of the examples of linear equation are 5x is equal to 9, 2x plus 3y equal to 8, 14x plus 2y plus 3z is equal to 9. And these are just some of the examples. There could be many more. You could take any example with just one or more variables and then you can form an equation like that. Now, are they all linear equations in one variable? No. Linear equation with the number of variable as 1 is said to be the linear equation in one variable. Now if you see these three examples above, we know that 5x is equal to 9 is a linear equation in one variable because it's just one variable, that is x. But in the second equation we see x and y as two variables. So that's not a linear equation in one variable, that's a linear equation in two variables. And if we see the third example, we have three variables x, y, and z. So it's linear equation in three variables here. If the left hand side and right hand side has only one variable and the others are all constants, then the equation becomes linear equation in one variable. Now the important thing here to understand is that the linear equation in one variable only specifies that the variable to be used has to be one, but that same variable could be used either only on the left hand side or only on the left hand side, or it could actually be used both on the left hand side and the right hand side. So it will still stay a linear equation in one variable. An example is 2x plus 9 is equal to 3x plus 5. Now here we see that the number of variable is just one, which is x, but it is being used both on the left hand side and the right hand side, and it still is a linear equation in one variable. So if we talk about what are inverse operations? In mathematics, we have two pairs of inverse operations, and we all know addition and subtraction is one pair and multiplication and division is the second pair of inverse operation. Now in equations, we use the inverse operations to shift something from one side of an equation to the other. And why we say something here is it could be a number, it could be a variable, it could be a term. So we are using, when we shift something from one side of the equation to the other side, that means the left hand side to the right hand side or from right hand side to the left hand side, then we use the inverse operations. So when it's moved to the other side of the equation, it gets the sign of the inverse operation. Say for example, we take ax is equal to b, and when we take a to the right hand side, x becomes equal to b by a. So a, which was actually getting multiplied by x, now b gets divided by a, because when a is moving from left hand side to right hand side, instead of multiplication, it takes the division sign along with it. Now what is transposition rule? So now we just talked about the inverse operations. Now when we apply that inverse operation in case of addition and subtraction, that is called transposition. When a number or variable in an equation is connected by the plus or minus sign, it could be taken to the other side of the equal to sign by prefixing the contrary sign to the term. If it's having a plus sign on the left hand side, then if you want to take to the right hand side, it'll get a negative sign, and vice versa. So if x plus a is equal to b, then if we want to take a to the right hand side, x becomes equal to b minus a, and this is called transposition rule. Now why do we actually want to do this transposition is because we want to isolate the variable x here. We want, if we have to find out the value of x or the possible values of x, in this case, in case of linear equation, it will be only one value actually. So if we want to find out the value of x, we need to isolate x. So that is why we would want to use these transposition rules. And the second thing that needs to be done for isolating the variable is exchanging sides when we want to actually keep the variable on the left hand side. Now exchanging sides actually does not require any change in the sign, and the reason is that when we are exchanging side, we are just moving whatever is there on the left hand side to the right hand side, and whatever is there on the right hand side to the left hand side. So effectively, if we had to change the sign, every single term would get a different sign, would get a changed sign. So it is equivalent to not changing signs at all. And what is exchanging sides? If we are to say a is equal to x plus b, we could also say x plus b is equal to a. And that is when we call it exchanging sides. This is where we don't need to change any signs. X is equal to a minus b is the change in the, it does not require any change in the signs. Now let's see, how do we solve linear equations? Solving linear equation means finding the value of the variable which will satisfy the equation. So say for example, in the previous slide, we had taken an example where we are saying x is equal to a minus b. Now that is when we know what is a, when we know what is b, we can actually find out the value of the variable x, and that is called solving the linear equation. So for solving the linear equations in one variable, what we do as a first thing is, as an important thing is, we take variable only on the one side, which could be either the left hand side or right hand side, although the preference is always to keep the variable on the left hand side. So if we see this equation of the type 3x plus 8 is equal to 5, or put it just by changing the sides, we can say 5 is equal to 3x plus 8. Now variable, if you see the variable is on one side, we agree, but the constant terms are present on both the sides. So what we want to do is, we want to take only the variable on one side, and we want to take all the constant terms on the other side. To do that, what we do is we make it 3x is equal to 5 minus 8, which means 3x is equal to minus 3, and hence is equal to x is equal to minus 1. So this is how we solve the equation 3x plus 8 is equal to 5 to find out the value of x. So let's now try to solve the equation where the variable is present on both sides of the equation. So let's take an example where the equation is 5x plus 9 is equal to 3x minus 8. Now all the terms with the variable are brought on one side of the equality sign, and the constant terms are taken to the other side using the transposition rule. So what we do is, we take the original equation 5x plus 9 equal to 3x minus 8, and then we move 3x to the left hand side, and we take 9 to the right hand side, making it 5x minus 3x is equal to minus 8 minus 9. That makes it 2x is equal to minus 17, and x is equal to minus 17 by 2. Equation. Let's now try to understand what is the application of linear equations. Why do we do them? Why do we actually, take the variables and what is the and create the equations and then solve the values of the variable? What is the real need of it? So now a number of practical life problems can only be solved by forming a linear equation and then finding a solution for the same. If we were not to form the linear equation, then there would be a hit and trial method, which would be a much longer approach. So let's try to see what do we need to find out. Now, some examples of the linear equation problems would be, first is the distance, speed, time kind of problems, where either the distance is given to us and time is given to us. We need to find out what is the speed of the vehicle, or any other two things could also be given. We given the speed and we given how much time did the vehicle take to travel from one point to another, how much is the distance between those two places. So those are the kind of things that we need to solve using linear equations. Then we have the kind of problems where part of the job is done and the rate of the completion of the job is given to you, the time is given to you, and then you need to find out how much more time is required or how many more people are required to do the remaining part of the job. Then there are mixture problems of the nature that if you have 5% water in 95% milk, and that kind of a solution is there, and then you have another solution of different with different ratios, you want to mix them, what is the ratio that you'll finally get? Then you have number problems where you need to find out one number based on certain statement as to this number is this many times greater than the other number and things like that, and you have to find out the number. Then there are money problems where you need to find out how much money would be needed if you were to buy certain amount of things and certain number of things to be taken. And then you have area perimeter problems. Obviously, the length and breadth of the rectangle is given to you, or the radius of a circle is given to you, and you need to find out its circumference. So those kind of things are require linear equations. And another one is basically some of the age related problems where you must have heard of the questions where we are told that my mother is 5 times my age, and today my age is 3 years. What is the age of my mother? Or 5 years from now she'll be only three times my age. What will be my age? So those kind of problems also come under the category of linear equations. We first create a linear equation based on the statement, the problem statement, and then we solve for it to find out whatever is not known to us. So now some equations, now we've talked about the linear equations which now in the first go are actually linear equations in one variable. We look at them and we say, oh, these are the linear equations in one variable. But then there are certain equations which do not seem to be linear equations in one variable, but they are reducible to linear equations. Let's look at some of those examples. Some equations have terms of second or third power of the variable. So when we defined linear equation, we said linear equations are those equations which either have just the constant terms and the terms with a constant multiplied with a variable with its first power. Now, but certain equations which have terms of second and third power of the variable, but they can be converted to linear equations before solving. Some of the one such example is, say for example, we have 3x plus 4 whole square plus 3x minus 2 whole square is equal to 6x plus 5 into 3x minus 2 plus 12. Now this clearly shows that we have x raised to power 2. So the second power of x is definitely coming in this equation, but let's try and simplify it. So when we open the brackets, it becomes 9x squared plus 16 plus 24x plus 9x squared plus 4 minus 12x equal to 18x squared plus 3x minus 10 plus 12. And when we simplify it further, it becomes 18x squared plus 12x plus 20 is equal to 18x squared plus 3x plus 2. And you can clearly see 18x squared being on both sides of the equality can be cancelled. Or you could simply say that we bring all the terms of x on the left hand side and all the constant terms on the right hand side, and here is what we get: 18x squared plus 12x minus 18x squared minus 3x equal to 2 minus 20, and that is where we get 9x is equal to minus 18, and that's clearly a linear equation in one variable. So x is equal to minus 2 is the answer for this. Then there are some other equations which can actually be reduced to linear equations. Some equations which have variable in the numerator as well as the denominator can also be reduced to linear equation, and let's look at one example for that category. So if you have 2x plus 3 divided by 2x minus 1 is equal to 3x minus 1 divided by 3x plus 1. Now the simple thing to be done here is to bring everything in the numerator and remove the denominator. So what we do is cross multiply the two sides and we get 2x plus 3 multiplied by 3x plus 1 equal to 3x minus 1 into 2x minus 1. Simplifying the two sides, we get 6x square plus 3 plus 11x is equal to 6x square minus 5x plus 1. And again, looking at this, it does not look like a linear equation. Neither the first one in the first step nor the one that we've gotten now does not look like a linear equation. But yes, of course, when we simplify it further, bringing all the terms of the variable x on the left hand side, we get 6x square plus 11x minus 6x square plus 5x is equal to 1 minus 3, and the x square terms get cancelled out and it becomes 16x is equal to minus 2 and x is equal to minus 1 by 8. So now let's look at another example of equations which are reducible to linear equations. Now certain equations which have variable only in the denominators, the past one that we saw was where the variable was there in the numerator as well as the denominator, but some equations have variable only in the denominators. They can also be reduced to the linear equation. An example would be 2 by x plus 5 by 3x is equal to 6. Now looking at this, if we take 3x as the common factor and we make it 6 plus 5 by 3x is equal to 6, and that makes it 11 is equal to 18x, and obviously we cross multiplied it also. So x is equal to, now 18x is equal to 11. This is exchanging sides and then x becomes equal to 11 by 18. Again, this got converted into a linear equation. Now let's try and see how do we solve some of the word problems using the linear equations. Now the word problem as such does not specify any linear equation. So we have to first read the word problem carefully, understand what needs to be found out, and represent this unknown quantity as a variable, say x. You could take any other variable also. You could say y, z or anything else, but here we're taking it x. Form an equation between the known and the unknown quantity. Solve the equation. Then check and interpret the solution in terms of the original problem. So one such example would be, what should be added to twice the rational number 5 by 3 to get 4? Now let's see what would be done. Now twice of 5 by 3 is 10 by 3. Linear equation becomes x plus 10 by 3, which is something added to twice the rational number to get 4. So x plus 10 by 3 is equal to 4. X becomes equal to 4 minus 10 by 3. This is transposing, and then x is equal to 2 by 3 as well. Now let's continue with solving word problems using linear equations. What else do we have to do? In word problems where more than one unknown need to be found, it is imperative that we use only one variable and the other unknown is used in terms of the first variable. Instead of defining two different variables x and y, we should first try to find out, can we define the second unknown in terms of the first variable? That is what will make it easier to solve. Say for example, now here the problem is my father's age is 5 times my age today. 4 years ago his age was 9 times of mine. What is my present age? Although in this word problem, what we have to find is my present age, but what is also unknown to me is my father's age. So one option would definitely be that I assume my present age to be x and my father's present age as y, but that's not what we should do, because then we'll have two variables and we'll not be able to solve it. Now we want to take my father's age in terms of my age. So now let's see how do we solve it. I assume my present age is x years. My father's present age is 5x, because it says my father's age is 5 times my age today. Then I say my age 4 years ago was x minus 4, and 4 years ago it says My father's age was 9 times of mine. So that means 5x minus 4. Because my father's current age is 5x. So his age 4 years ago was 5x minus 4, and that is 9 times of my age at that time, which is x minus 4. So 5x minus 4 becomes equal to 9 times of x minus 4. Solving this for x, we get 5x minus 4 is equal to 9x minus 36. We say 5x minus 9x is equal to minus 36 plus 4, which makes it minus 4x is equal to minus 32. X is equal to 8 years. So my current age is 8 years and my father's current age would be 40 years. Let's start with the quiz on linear equations. The first question is, find x in 2 by x plus 3 minus 4 by x minus 3 is equal to minus 6 by x plus 3. And these are the options. Try and solve them. At the end of the quiz, we'll find the solution of the linear equations questions. Okay, the second question is, in an exam, a student attempts 80% of the total questions, of which 60% of his answers are correct. Each question gets plus 3 for correct answer and minus 1 for incorrect answer. If the student secured 224 marks, what is the total number of questions? So here what you have to do is, you have to again form a linear equation using all the information that is present here, and then try to find out the total number of questions which were there in the exam. The options are 100, 150, 200 and 130. And let's look at the last question on the quiz. In a rectangle ABCD, its length is 3 times its breadth. If the length is decreased by 3 and breadth is increased by 5, its area increases by 57 centimeters square. Find the perimeter of the rectangle. So you have to find the perimeter of the original rectangle. So these are the different options. Let's look at the solutions for the first quiz. Find x in this equation. Okay, so what we're trying to do here is, we are taking the common factor of the denominator as the denominator, and then taking the LCM of that, and then we try to solve them as we do it in the normal arithmetic operations. So it becomes 2 into x minus 3 minus 4 into x plus 3 whole divided by x plus 3 into x minus 3, which is equal to, the right hand side does not change, minus 6 by x plus 3. Now we can obviously cancel x plus 3 on both the left hand side and right hand side denominators. So we get 2x minus 6, and we are simplifying it here. We get 2x minus 6 minus 4x minus 12 divided by x minus 3 is equal to minus 6, and then we'll now cross multiply and we'll make it minus 2x minus 18 is equal to minus 6 into x minus 3. That gives us minus 2x plus 6x. Now we are transposing. Minus 2x plus 6x is equal to minus 18 plus 18. That makes it 36. So 4x is equal to 36, x is equal to 9. So option A is the correct answer for this. Now let's look at the solution for question 2. The question says that in an exam, a student attempts 80% of the total questions, of which 60% of his answers are correct. Each question gets plus 3 for correct answer and minus 1 for the incorrect answer. If the student secured 225 marks, what is the total number of questions? So since we have to find the total number of questions, let's assume that to be x. Now total questions which are attempted is 80% of x, which is 0.8x. The total correct question is 60% of 0.8x, which makes it 0.6 into 0.8x, which is 0.48x. Now the total incorrect question would be the questions which have been attempted but have been attempted incorrectly. So that would be the total number of attempted questions minus the total number of correct questions, which is 0.8x minus 0.48x, which makes it 0.32x, are the incorrect questions. Total marks for the correct questions would be 3 into 0.48x, because the question says he gets plus 3 for each correct answer. So that makes it 1.44x. And total marks for the incorrect question would be -1 into 0.32x, which is minus 0.32x. So the total marks obtained by the student would be 1.44x minus 0.32x, which is 1.12x. And the question states that the students secured 224 marks. So 1.12x will be equal to 224. So x is equal to 224 divided by 1.12, and that says that x is equal to 200. So there were total 200 questions to be attempted, out of which the student attempted 80% of the total questions. So option C is the correct answer. Let's look at the solution for question 3. So let's take the original rectangle ABCD, and the breadth of that rectangle is x, and the length is 3 times its breadth. So the length becomes 3x. The area becomes 3x square. Now let's take the length of the new rectangle which is formed, which we take as 3x minus 3 will be the new length, because the length is decreased by 3 and the breadth is increased by 5. So the new breadth becomes x plus 5. So new rectangle A dash B dash C dash D dash has the length 3x minus 3 and the breadth x plus 5. The new area would be 3x minus 3 into x plus 5, which is equal to 3x square plus 12x minus 15, and that is, as per the word problem, as per the question, it increased by 57 centimeter square from the original area. So original area was 3x square, so 3x square plus 57 should be equal to 3x square plus 12x minus 15. So now, since these two, if you look at the equation, it has the power of 2 of the variable x, but since both of them are equal, it can be reduced to a linear equation, and it becomes 12x minus 15 is equal to 57. 12x is equal to 72 and x is equal to 6 centimeter. So now we know x is equal to 6 centimeter, 3x will be equal to 18 centimeter. We're supposed to find the perimeter of the original rectangle, which is A plus ABCD, which is twice of x plus 3x, which is twice of 6 plus 18, which is 48 centimeter. So the option A is the correct answer. So students, I hope you enjoyed learning the linear equations in one variable. So now play more with the variables x, y, and z. Don't get scared of the variables. They're just another, way to solve the problems which we come across in our daily lives. And I'm sure you'll enjoy doing the variables as you get more clarity into what we're trying to do. So that is the key here. Now stay tuned for more such sessions coming up on the channel in the coming few weeks, and you can visit us at Cool Smart Learning website and the Cool Smart Learning channels. Thank you.